Okay, let's get started. Welcome everybody to Webinar Wednesday. This one is about sustainability with Creo AMX. I am your host, Michael Bork. I have been, a little bit about myself, I have been in and out of manufacturing for the last 36 years. I actually was a manufacturing engineer at MIT doing a lot of design and engineering and doing digital transformation, moving from CAD, from drawing boards to CAD. Then I went to go work to PTC and worked at PTC as a vice president and helped lead a lot of the efforts behind Creo Wildfire, which is what we're going to be demonstrating today, which is some features and functionalities around Creo Wildfire. I'm sorry, Creo, and the capabilities that I'm going to show you today around additive manufacturing. I'm also joined with my colleague Terry, who is someone that I work with quite a bit. He's also my friend. We talk every day. Between us, we have almost 67 years of experience in the industry, and he's here to help me answer any questions that might come in the comments and so forth. So if you want to ask some questions, please do so in the comments section. I'll be giving a demonstration, and why I'm excited about and showing you this picture here. This is the world's fastest animal punch. This is a peacock mantis shrimp. I don't know if anybody's ever seen anything like this. It's only a few centimeters long, but it can pack a powerful punch, and what it does is it punches its prey at the speed of a .22 caliber bullet. Think about that. It's tiny. How does it do that? Well, it uses this very little intricate, and it's been studied, this very intricate joint that scientists have been studying to understand how it can absorb and retain and build out the amount of force needed to, to generate that amount of ridiculous acceleration, as explained. When you zoom in and you look at this stuff, it's actually these cellular structures. It's more like a ratcheting system. What happens is the animal starts to crank up its arm a little bit at a time, and each time it takes a little bit of energy, but it keeps building and building and building. And then at some point when the creature is ready to kill its prey, it punches it out and kills it instantly with the speed of a .22 caliber bullet. So it's quite a very interesting story. I have it cited down here for you to look at. But we're getting, what's exciting is we can start to do this sort of stuff in Creo. What I'm showing you here is an animation. This is not the mantis, but this is a Creo lattice that I created, and I'm showing you that this has been created in Creo, and it's immensely dense and very complicated set of geometry, but it's created with one feature called lattice, and it's one of the best features in additive manufacturing that you can take advantage of, that I'll be talking a little bit later. But just look at how complicated and interesting that shape is. So this gets me excited about what you can do. You can actually do a lot with 3D printing these days. I have a 3D printer in my basement. I hope you do too. I find that there's a lot of sustainability play that you get with additive manufacturing. But what I want to tell you today is that the I should back up and say that the additive manufacturing extension comes with a T3 license. So if you are a T3 license holder, you already have experience. You already have the additive manufacturing extension. You have the standard capability. You can also buy it as an a la carte feature. And what it does is it lets you do what I'm going to show you in a little bit, but it lets you take parts and it lets you add these lattice materials inside them in various different forms. You can choose different types of forms. There's different types of beams and lattices. You can run analysis on these various items. And then you get some help packing a tray so that you can print a lot of these all at once in a printer setup. So this is the kind of capability that you get with the Creo additive manufacturing extension. There is yet another extension that is available. I have access to all the capabilities, but I did want to point out there is a whole other area of printing, which is metal printing. I won't be covering much of this today, but this is the advanced part of Creo, which has an integration with Materialize. You know, when you buy a metal printer, which is a big piece of capital equipment, it's expensive, and it comes with its own build processor, and it comes with its own little problems. And Materialize is a product which is like a build processor. It's like a slicer, and it helps you get the parts on the tray accordingly. I want you to notice this part here looks like a stamping. And that's what's interesting and sustainable about 3D printing, is that I've met people who say they just need one of these. They don't want to go through the trouble to go through and make the stamping that's needed to make this part. We're at a point now where we can actually design things, and we can print them, and we can prototype them, we can refine them, and then we can further after we prototype these things, we can actually do the work to make the stampings if we want to mass produce. But some of the capabilities that you get with this capability here is the ability to wick away heat, and dealing with heat and thermal when you print with metal is a big deal. So that comes with the advanced part of Creo. So I want to step back. Imagine if I got hit by one of those shrimps, and I'm actually allergic to shrimp, I would need to sit down or lay down on a purple mattress. I thought I would show you, and I thought it'd be fun to explore that a purple mattress is indeed a metamaterial. If you don't know what metamaterials are a form of biomimicry. We all know that a honeycomb is created in nature, and so are other shapes, and these are all forms of lattices. Now, this part here was created with just one lattice feature. I know there's lots of ways that we could think about creating something like this, but I thought I would show you that right away I've redefined the lattice, and this is a 2.5D lattice, and I'm pointing it in the Z direction, and I've even specified which corner that I want it to be, and if I zoom in, I get all these little handles. I'm going to warn everybody to stay away from these handles. These handles can actually be a little bit bizarre to work with, so what I like to do is to recommend that you actually type in your values. So in this particular case, I've chosen a square. What would happen if I chose a rectangle? I'm sorry, a triangle. Okay, so I'm just going to click triangle. I'm going to click OK. And suddenly my material should change. And now I've got a purple mattress in a different form. And I've actually taken this and done a live simulation to see what the effects would be if I actually did lay down on this mattress. So there's a sort of a figure of some pressure. I actually typed in my weight, and I can deform this. Oops, that didn't look very good. Hold on a minute. Animate, deformation. Hold on a minute. It's just happening there. Animation options, speed, scale, play. There we go. Look at that. So I could flip between different types of lattices and run these kind of simulations, and very easily, see what the impacts are going to be. I've actually simulated this as foam, and this is just a simulation of where the impact would be with this divided surface that I put on here. Let me go shut this off and turn off the deformation and shut off the some of the points there and get back. I want to create a new part from scratch and show you how to create a lattice in the first place. What I'm going to do is I'm going to first, I've got Creo here. I've got Creo, by the way, this is Creo 10, and I'm also going to be showing Creo 11. I'm going to be showing a new capability in Creo 11 that has the capability to actually connect lattices together. But let me show you very simply a very simple basic demo. I'm just going to create a block here. I'm just going to create a block very simply here. Hopefully you all know how to do what I'm doing here. And in Creo 10, they added a great feature. So your very first dimension, I can type in and it automatically scales, which is beautiful. Saves me a lot of time. 150. There, I've got a box. Okay. Now, I hope that everybody on the call here has experienced using bodies. Right now, every time you create something in Creo, you're creating at least one body. And there's cases where I may want to specify an area where I would like the lattice to be. So I'm gonna, for the purpose of this simple explanation, I'm going to go into the lattice by going to the engineering tab up here, and I have something here called lattice. Okay, and the very first thing it's going to ask me, it wants me to replace the body with lattice. So I'm going to click replace. And it's the UI here, it goes from left to right. This is basically a beams type lattice. And I'm going to give you a little tip here. Don't use full geometry for now as you experience and play with this and simplify it. I'm going to go with simplified, and I'll explain some of that later. But let's just go see what is created with the defaults. Look at that. Look at that structure there. That's quite interesting how that was created. Now let's go and see what other types of stuff we can create by redefining that lattice. So this is the one that's called beams. Like I said, I don't recommend moving any of these with the draggers. I would work directly. There is a capability here called scale. Scale works. If I wanted to make this double in size, I could hit 2 and I would double that. And now I've got the scale accordingly, and it's scaled everything. It scaled the ball, it scaled the beams, it scaled everything. Let's go back and take a look at what some other things I can do beyond beams. By the way, I have these other types of figures I can create. Quasi-radial. I can say that I want 6 sections of this and see if it will let me take that. And I'll get a sort of a little bizarre shape here. Okay. And if I realize that's not the right scale, again, I can keep redefining this feature over and over again and changing the scale down. So if I want to go down a little bit, I'm going to type in 0.25 and see what kind of a structure we get. There we go. And you can 3D print this. There's materials out there. I could 3D print this in my basement with a soft material. I've seen printers that can print and perform. One thing I want to show you about the lattice that I haven't explained yet is that I'm just going to switch this back to something more normal, like regular, and maybe I'll change the cell type to triangle and change beams to something called 2.5. This may make a little bit more sense for people. Let's say I was making a heat exchanger and I wanted to create something like that. Maybe I want that to be a substrate where I plan on putting a piece of material on one side, piece of material on the other side. Let's go ahead and redefine this. And I'm going to show you that the lattice capability also has an extra feature called create shell. So if I create shell, I can say that I want my body to have a 5mm shell on the inside, and I'm going to pick 2 surfaces. This surface, I'm holding the control key. I'm using a space mouse, by the way, to spin my model, and I'm going to click that, and let's see what kind of geometry that creates me. So now I've got something that is like that. So, you can create all kinds of interesting geometry, and I find people creating building facades using, I'm going to have a couple of examples of other stuff that I've created with lattices. One thing I want to show you, though, I've been showing you this simplified, but I want to show you what happens if I go to full geometry. This is where the power of Creo really comes in. Full geometry has given me all full geometry. This is all geometry. I can go in here and I can add a round. If I wanted to, I could add rounds in all these areas here if I wanted to. For some reason, these were areas that I wanted, to have rounds in here. So this creates real geometry, and I think that's a very powerful feature. All right, I'd like to get back to the slide deck for a minute since we covered a few things. There's a few other things that I want to demonstrate. I want to demonstrate to you a capability which I really like, which is called build orientation. I've been given this part by an engineer who really wants this part printed at a certain angle because of strength considerations. He's a manufacturing engineer. And I'm going to show you in a minute how I'm able to pull this part into Creo, and I'm going to able to specify and have it find its own computed optimal orientation, which will find the least amount of material that'll be used and the least amount of contact area that will be required on my printer. I'm also going to show you how that graph works. I'm going to show you that in just a minute. So let me give you a demonstration of that. So I've got this part here. This part does not have lattices in it. It could have lattices in it. And my question is, what direction should I print it in? I could look at this thing all day long. I have ideas about how it could be printed. It could be printed this way, but the engineer told me he didn't want it oriented in that direction. So I'm going to go into the Analysis tab. Usually I'm in the Model tab. And I'm going to go into the Analysis tab up here. And I have an area called Build Direction. I've already created a build direction, so let me just go and recreate it. All right, so I'm going to click Build Direction. And it's going to ask me a question, where is the tray? The tray would likely be that surface there. Okay, and there's a number of settings that I've already put in here that I've got from my engineer. These are the down-facing angles, critical angles, all these sort of things. And I'm going to let Creo sort of calculate automatically what is the best orientation given my particular printer needs, conditions. So this is computing. It shouldn't take very long, but it's going to, okay, it's already done its job. I click OK. I click OK. And now it's given me a new coordinate system called build direction. Okay, and if I look at that build direction and sort of orient it accordingly to a Cartesian coordinate system, you can see that it wants to print the part like this. If I redefine the feature, it'll show me, like I was showing you earlier, the areas where it believes the minimal areas would be. I've actually 3D printed this part, and I'll show you in a minute that it actually printed just as Creo has indicated, leaving these yellow surfaces fine. The red surfaces were a little bit dusty, but the part printed okay. But I'm going to show you a little trick that I think is going to be very interesting. And that trick is this. So I don't have a metal printer in my basement. I normally could go into File, Print, and Print, and go to Prepare for 3D printing. But because I'm using a 3D printer in my basement, I thought I would show you a trick. How can I get this orientation into my slicer? I happen to be using a Bamboo 3D printer. I hope some of you have access to 3D printers. I think having a 3D printer is a sustainable play in the first place because you can prototype and you can make all kinds of stuff. Well, let's see what we can do with this build orientation. I'm going to actually go back to the Model tab. I'm going to go into plane. I'm going to drive a plane through that and get that going in the Z direction. All right, so I've got a plane there. See that right there? I'm going to make that just go through. I'm going to click OK. So now I've got a plane. I'm going to create some sacrificial geometry, something I'm not planning to print, but something that gives me some space. I'll just sort of snap to this. I'll draw a little circle. Click OK. I don't really want it to intersect, so I'm just going to make this little tiny little disc here. And all I'm doing is I'm creating myself some sacrificial piece of geometry that I can use to orient my part when I put it on my own build tray. All right, so now we may be interested in exporting this. One of my favorite formats, I used to like STL, but I don't like STL anymore. I've now moved to 3MF. There's a capability here. You can go File, Save as a Copy. I can pick 3MF as the format. And I want to show you this Options tab. One of the neat things that it does, if my part had lattices in it, we would be using a smaller file format because the way the files are sent in 3MF, they sort of package up the recipe for the lattices inside the file so that you get a smaller file. These are on by default. I'm going to leave them on by default. They don't really matter right now because I'm not using any lattices, but I just want you to know that's a new capability in Creo 11 actually. So I would go with those options. The next thing I would do is I usually click customize, and I do that because I like to, I'm just gonna let this recreate what it's doing. That's fine. Yeah, is you can type, see this chord height? A lot of people don't know this, but you can type in 0. And when you type 0, it'll find the smallest chord height possible. And I just click OK, and it's actually saved that file to my desktop. Why don't I show you what would happen if I took that part into my 3D printer? This is what happens. I brought the part into the 3D printer, and I now need to take that sacrificial geometry that I created and get it oriented. And this slicer that I happen to be used, which is sort of like a build processor, comes with the printer, has a capability for me to orient the part and lay it flat. So I'm going to look for that area that I had there. I think it was right there. And now the part is laying flat, and that's the orientation it wants to print it in. Okay. And this tool lets me move and get rid of that other object, so I don't care about that other object. And then I can go over here in my slicer, and I can kind of control all the various kind of settings that one would have. I'm definitely going to need support. I'm probably going to need tree support. Let's see what this does. Okay, and I actually have a picture of this prepared to show you what it looks like. I'm going to go back to my presentation, my slide deck here. So here's what we did. We took the part and made use of it in the slicer, and then I was able to orient it and get it to look like that. And I actually printed last night. It took only 3 hours to print that part, and that part was actually half the size. I scaled it. I actually printed a bigger version, and it printed out really, really nice. I thought I'd give you a picture of what it looks like. Here is that part being printed on my printer. I actually have a little video that I can play with you. And hopefully you can see what that looks like, how it adds layer by layer. And you know, these support materials, they may look like they're a lot, but they just snap right off. And the part was really strong. I measured it with calipers. It was extremely strong, and I decided to print another one. But I want to show you that this is the resulting part. And I used a pencil to illustrate everywhere that Creo predicted that it would have an area needed, it would have difficulty and need support, is exactly where it landed. All these little areas here I was able to kind of sand. They're not really important to me. The part performance was actually really important. The dimensions and the scale was really important. And again, this took 3 hours and 42 minutes to print. And I love that I can go from art to part. I love that I have this part. I don't have my camera on, but I'm holding the part in my hand right now. And I was showing my wife the other day, and she was like marveling at the fact that you can take a part from anywhere that was designed by anybody and print it and have it in your hands and have a actually real discussion, you know, hold it in your hands. So that's the kind of stuff you can do. We take a sip of water for a minute. A few other things that people are doing with metamaterials. In one of the metamaterials you can create is a gyroid. A gyroid is a very interesting type of metamaterial. It's not found in nature, but it should be. I'm showing you this picture over on the side. This is not really the greatest illustration of what a heat exchanger does, but I think you can understand that a gyroid is a sort of type of infill or type of lattice material where the two fluids do not interfere with each other, but they get very close. So I want you to imagine that the red that you see is hot fluid. Could be liquid, could be air, could be gas, could be anything. The green is a whole other fluid that's moving around. And the blue is the region in between that's stopping the two fluids from actually getting too close. But notice how thin that blue region is. And that allows this heat exchanging to go on. So I don't have a good example of heat exchanger, but a lot of people are actually using lattices and using gyroids to create heat exchangers. I'd be interested to hear if anybody on the call here is doing that. And talking about heat exchangers, I actually got a chance last year to work on a NASA heat exchanger. It was really more of a radiator. They had a mission that they needed to take, and they had no idea how to fit a radiator around the vessel. And I came up with this design, and I wanted to see if it would print on my home printer, and it looked terrible. As you can see, it doesn't look good at all, and that's because I didn't orient the part accordingly. So here is the part that Creo wants to print the part. I'm actually in the process of printing this part again. This part would typically be made of metal, but I'm printing it in plastic to show you here. It's actually printing right now in my basement, and it's about 6 hours of the way through, so we'll see how that comes out. But it just goes to show you that you can predict and understand what's going to happen at the print before it happens. A few other interesting things you can do with lattices is I came across this article where someone, Oakley or some bicycle company, was bragging about the fact that they have this new bicycle grip that's better for sweat. It's rubber. And I thought, I could create that in Creo. And so that's what I did. If you look at the model tree here, it's very simple. It's just a very simple cylinder with a nice rounded area here, the hole. And if I were to zoom in here, I think you could see there's a little lattice here. And this happens to be a stochastic lattice, which is a certain type of lattice which is randomized. So there's almost, as you look at this, it's sort of like Mother Nature. It has no starting point, has no end point. It seems to, sort of flow naturally. And I actually have been given this file to a friend of mine who's got a powder bed fusion printer, and he's going to print this out of TPU material, and we're going to test how it works. But you can use lattices in that way as well. Another application that I see lattices being used, a very exciting application, is in medical. This is a very primitive model that I created to simulate what it might look like if you were to get a vertebrae in the back of your back replaced. There are companies that are using lattices like I've shown you to create parts that look almost like this. What's interesting about that lattice, those windows that you see on the side, is that the bone actually learns to grow through that material, making it a permanent implant. So science is really advancing us beyond screws to hold these things in, to actually now where we're creating in 3D printing parts that go in your body. This has been FDA approved, and there's even been an FDA approval for some materials, some plastics, such as PEEK, to be actually implanted. So there's a lot of great advancements happening in the medical and bone implant sections using lattices. And thought I would end on this one. I saw a few years ago, or actually just recently, this basketball, this airless basketball. I have no idea why this became sort of famous, but I think the basketball company wanted to try to do something related to 3D printing. This is a $1,700 basketball that you can buy. It's airless. It supposedly plays well. I wouldn't pass it around in water. It won't float for sure, but I thought I could create it in Creo. I was telling Terry earlier, he was asking me how I created this, so I just thought I'd explain a little bit about how you can use these lattices. This was all done with lattices. Those are just lattice shapes. And all I did here was I created a sphere. And then I sectioned that sphere surface into 90-degree sections. And then I used this feature called flatten quilt. It's kind of an amazing feature. And what it does is it takes this sort of teardrop looking shape. And then I was able to thicken it with the thicken feature. And then I gave it some extrusion around the outer edges, which you see right here. And then I did a lattice on it, and I chose that pattern right there because that's the one that that they had in the model, and I've been able to recreate it. And then afterwards, I used the flattened quilt, which basically unbends the quilt this way, and I just patterned it 4 times. So so that's how that works. So before I go to questions, I want to show you something interesting about Creo 11. I have Creo 11 here loaded here for a minute. I think I have, let me see which version this is. Help about Creo Parametric. This is Creo 10. I need to go to Creo 11, which is right here. Yeah. Let me just close this session here. Close that session there. File. Lattice testing. So I'm using Creo 11, and a lot of customers that are using lattices have asked, how do I connect lattices together? So I've got 3 simple bodies that I've created. One is red, one is yellow, one is blue, green, and I'm gonna resume these features to show you what lattices look like. So this lattice here is of a certain type. I'll redefine it so you can see its definition. You can see it's got a cross section of, it's very hard to sometimes see. That's why I like using the values up here. So it's got a target cell size of 25, and it's going to be a trabecular shape when that's been specified by the design engineer. And so, and this is, by the way, a stochastic beam. There is also auxetic beams that you can set. If you don't know about auxetic beams can do sort of negative Poisson's ratio. But this one right here is just going to use stochastic beam lattice, and I'm using the Varani diagram for that. So let's see what that creates. Okay, that creates that lattice. So let's resume this lattice and take a look. I wanted to create a lattice that was much more dense. So see how this one on the red is less dense, and my theory is that bone would easily start to grow through the red, but eventually I wanted it to start to kind of grow and bond into a much more thicker area. So I've got these 2 lattices right now, but notice as I zoom in on these things that these balls aren't connected. These are called dangling beams. We would not want to print anything like this right now because we cannot have these kind of dangling beams sitting around. And that's where Lattice Connect comes in. So I'm going to resume this feature here. And I have the last lattice, which is a whole other different type of lattice. Let me just redefine this here. It's very powerful. This one here has got a target pore size of 15. So the porosity is much bigger. I'm using, instead of target cells or number of cells, I'm using target pore size of 15. Okay, now all of these have been created using simplified representation, and that's really important if you're going to take advantage of this capability I'm going to show you. So all these right now have been created as simplified. What Lattice Connect lets us do is, I'm going to just resume the feature, and you're going to see it's going to propagate this first lattice all the way through to the next one, connecting every beam so there's no dangling beams left. And there's settings that let me inherit things like ball size, beam size, and so on. So let's see what it creates here. It's going to create one unified red lattice. It does take a little bit of time to calculate. There we go. Look at that lattice there. That's just what I'm looking for. It's dense in the middle. It's sparse on the outside. I can do a sort of cross section on this if I want to see what that looks like there. And so let's look at Lattice Connect for a minute to show you some of the features it lets you do. Hopefully this is something you guys would want to use. See that it has this ability to inherit parameters. So it's going to inherit the first parameters of the first lattice that I chose. There's an order of operations. There's a second lattice that I've chosen, and the third lattice. So I'm using the first lattice as sort of its, I want to inherit all those properties. If I didn't, I could uncheck this, and we can see what the results would be of that. I'm expecting ball sizes to change. I'm expecting, well, let's see what happens. You can see that it's counting up here, 34%. And it's really good to have a good, powerful computer when you're working with lattices. It can be pretty intense on the CPU, but it creates really beautiful looking geometry. It's almost done here. Okay, look what it's done there. So let's see, it gave me different parameters because I didn't let it inherit the parameters that I said I would before. So if I go through here, I can change and make all these diameter changes, but to inherit them, I just click this. There is ways to drive density and uniformity. I won't control and do those, but you want to pick full geometry when you're done with this, because then you can be able to 3D print it. So let's just let this finish. It's counting up. And again, it should give us one unified lattice. And this is a great capability that's been added to Creo 11, and it's based on customer feedback. I get the opportunity to talk to thousands of customers, and a lot of customers are using these capabilities, and they tell me they want this capability, they want that capability. I bring some of that information back to PTC. But you know, this is all done in Creo, and you can combine this with whatever it is that you're making to really, you know, move to the future. You can now 3D print these types of structures. You can actually perhaps even throw the punch of a shrimp, which is an amazing story. So that's the demonstration. Let me go back to my slide and see if we have any questions in the chat. Hopefully I asked you in the beginning. If I didn't, if you have questions, you can put them in the chat. I'm going to go ahead and take a look to see if there's any questions. Let's see here. This might do a big window effect. So for me to see questions, I can see this question. Can lattice be placed along a surface other than Creo as a fill? No, it needs to work on bodies. It cannot work on just a surface. You can extrude that surface very thin, but no, it works on bodies. So that's the answer to that question. Thank you for that question, Kyle. I'm going to turn off this here. Yeah, I really love additive manufacturing. I think it's a very cool technology. And you know, I'm using Creo about 6 hours a day, and I love 3D printing parts that people send me. And I encourage you to get into 3D printing and use sustainable practices to actually advance the state of art with your products. So let's see if there's any more questions before we wrap up. I don't know if there's anybody listening. I see Kyle Lampson's there. Thank you, Kyle. Kyle Lampson, thank you for joining. You know, that's another interesting thing that's been done with Creo lattices, is that you can create helmets that have a lattice material in between the helmet, outside of the helmet, and the wearer's skull, and it can be used to absorb impact. So I know that that's been used in another application as well. So that's it. That's my demonstration. I hope that you enjoyed today. This will be made available at the end through a video, I'm told. There'll be a video on YouTube posted as well. And if there's any questions you have, you can send them to me. I am very easy to reach through email. I'm all over LinkedIn, and I hope that you reach out to me. And I hope that we can have a conversation about additive manufacturing and where it's going. It's a very exciting field. For me, additive manufacturing unlocks the power of geometry. We were stuck in the dark ages with subtractive machining. Now we can add and we can create, we can subtract, and we can divide. So it's a really cool piece of technology. So that's it. Thank you very much, everybody.